Hello, this is Nicholas Rosano, and this is my problem, my computer science problem. And it's basically just the Fibonacci sequence. I don't know, it's the first week, I'm kind of getting used to it, so this is a little simpler, but I decided to put it in. I mean, it takes user input, and this is technically my pseudocode, but I mean, it's actual code, and it does work. Anyway, the obviously the time complexity of this, because of the way it works, is o to the n power. So in order to do this, you have to calculate the time complexity. What I did is I got the standard equation. I used t in this case. T of n is equal to t of n minus 1 plus t of n minus 2 plus c. I don't know. And that's basically the sequence. The Tn minus 1 and Tn minus 2. They should basically be like one apart, you know. So in order to be T of n. So this is for the upper bound, because the lower bound, I didn't really bother with that. I just did the upper bound. Sorry. Alright, so the way we get that, and then we assume that T of n minus 2 is like less than or equal to T of n minus 1. So with that knowledge, you can change the equation to 2t of n minus 1 plus c. Then, you change it to 2 times 2t of n minus 2 plus c, 4t of n minus 2 plus 3c, 8t of n minus 3 plus 7c, and you get to the power k, which k is going to be my basically a placeholder, and it's going to be just t of n at the end, but we have to solve for n minus k equals 0 in order to find it, and just hearing that alone you could probably tell that it's 0. So we take the equation 2 power of k times t of n minus k plus 2 the power of k minus 1 times c, and we substitute that, and then we just get 2 to the power of n times t of 0 plus 2 to the power of n minus 1 and then times c, which can be further simplified to the power of n times 1 plus c minus c. And if you even further simplified, you just tell everything else is a throwaway term, that 2 to the power of n is what we were looking for. So therefore it's 2 to the power of n. The reason it took so long is because this is a recursive function, and honestly you probably just look at it and tell what it is, but I don't know, I just wanted to be thorough. As for brute force, that's a lot simpler. You just take I don't know, like let's say f of n, which whatever you want it to be, let's say it's 4 maybe, and if you were to plug that into here, which actually I'll do it, just help myself, put 4, you get 1 plus 1 and 2, and you can probably guess that it would have been 7, but I included 0 in this, so it's just 4. So 4 equals 4, and basically you just add that up, which would also be 4, which is coincidence, right? And that's pretty much it, and it's O of n. And the reason I said like the space complexity would be, I don't know if I put it here right, is it's actually O of n, because I put in a user defined have an actual n. Like if it wasn't, it would have just been linear. It would just been constant with no changes, but it is technically linear in this case because I am putting in a number. It does go up. If I only put in like say 4, it just stops, so that would be constant. But like you can pretty much put any number in. So so the last thing is the asymptotic the cases, whatever. This is given like you have a chart, you could probably tell this is technically it's in the worst category. Like it's one of the worst. It's not the worst, but it's up there. Like there's things that are like n factorial is obviously going to be bigger, but this is pretty much as bad as it will get when it comes to what you put in here. Well, that's about it. I don't know. You can see I already tested my program, so I don't really need to test it again, but I don't know. I'll put in let's say 10 just to show that it works. See 1 plus 1 is 2, 2 plus, I don't know, 2 plus 1 is 3, 3 plus 2 is 5. You know what Fibonacci is. So, well, that's my video, and I'll have slides for a presentation too. Alright, well, I guess that's it. Oh, almost forgot. I have to actually explain how the code works. I mean, I already put up helpful little comments up here. You can't really see most of this, or it says this is would be. I don't know. Here you have, you have your I, which is pretty regular. You have your N, which in this case I'm using it as user input, which it normally would be. And then I have my num1 and num2, which is what I use to actually make the thing. And what I did is I used the swap function, where I use a temp. I just called it temp. And it works pretty well for Fibonacci because you have, you have the last value added by the one before that, and I basically put that in here. And I don't know, I guess that's pretty much, I asked for the user input, and then, I don't know, I print this, put it right here. Okay, now I think that is pretty much it.